Like usual, I'll wait a little bit to get moving, but if anybody's got any questions, I'm happy to field just about anything for a few minutes. Okay, I guess I got started. So first thing I'm going to do, like usual, this is a template-based one. I was told in Slack, and I realized that this particular link to the template wasn't correct until a minute ago. But if you use the key up here, you would have been just fine. I must have messed that link up at some point. Okay, so I'm basically just going to go ahead and save link as. I'm just going to huck it somewhere random. That'll do. And start with that. Yeah, go ahead and missed it. 30th already. Good Lord. Okay. Let's see. I need the open data year one. So it's important you make sure your RMD is in the same folder as the open data year one. So I'm pretty sure I've got it in this one, so I should be fine. Yep. Okay. So I'm just going to go ahead and run this all the way down to the bottom of part one. Might get some errors if you use the key. There's a couple pieces of dated code in here I forgot to update in the key, but they work perfectly fine. Okay. If you have any issues getting to that point, let me know, but the most likely thing would be not putting the RMD in the same folder that the open data year one folder is in. It should be about the only thing that could cause a problem. Wait 1 second, make sure folks are generally to this place. At this point, you should basically just have a data list object, which contains a whole pile of stuff. Should be kind of monstrous. There should be a station data frame, a trip data frame, and a weather data frame. It should have clean date objects for dates, date time objects like this for start time and stop time. All that stuff we kind of finished up in the first section. Okay. If you got that, we're in business. What we're going to do for this homework is we're going to start by writing and working with a couple simple functions. The first one is going to be a very simple function that just extracts some text from a variable in our data set. And we're going to work our way up to a function which will draw ggplots for us, giving it only a couple basic parameters. So we don't have to do the whole structure of the ggplot. We let it kind of take care of that for us. Okay. So in the station data and the trip data, there are columns like terminal, to station ID, and from station ID that have a 2 or 3 character code followed by a hyphen and a numeric code. So if I grab this, for instance, take a quick peek at it, in the station data, you'll see that there's like an ID for the station, sort of like general unique ID. There's a name for the station. And more importantly, there is this terminal column that has things like BT-01, BT-03, blah, 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 CBD, SLU, CBD, okay? So what this is a code that indicates the region of the city the station is in. I believe BT is Belltown, CBD is the Central Business District, SLU is South Lake Union, right? There are multiple stations in each one of these regions, so you have Belltown Station 1, 3, 4, 5, blah, 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 right? What we are going to do is write a very simple function that will extract the BT, the CBD, the SLU, all of those from this, and discard the dash number. All we want is the region code extracted from this. We don't care about the specific number of the station. Okay, so what we're going to do is we're going to write a function called region extract. And what it will do is it will take a character vector as an input, and it will return another character vector as an output. It's going to take something like CBD11 or ID-01 and return just CBD or ID. Okay, so if I want to create a function named region extract, how do I start? What is the framework for creating a function named region extract? How should I start? Well, in R, what is a function? In the broadest possible terms. A function is a type of what? What is everything in R? Yeah, it's an object, right? A function is an object. So how do we create objects? We assign a name to them. So if we want to create region extract, what is that going to look like, right? Okay, so we'll have a name for it. As suggested in chat, region extract, and assignment to it. If we want this to be a function, how do we go about making this a function? Yeah. We make functions with the function function. The function function makes functions. Put some squiggly brackets on here. And the actual function, everything it does is going to be inside these squiggly brackets. Okay? So as an example, I put up here, we want our function to work like this, so that if we run this code right here, it will spit out something that looks like this. Technically speaking, what it should spit out will look like this. It should sit out, not CBD01, but it should be ID. Okay, so if we give it CBD-11, it should produce CBD. If we give it ID-01, it should produce ID. Okay, so if we're provided with this vector right here, I'm going to call this test vector. What code, not necessarily in the function, what code might you run to translate this test vector into something that looks like this, the CBD and the ID? What might I do to that? You could suggest a function. You could suggest the entire text. We could try to do it with substring. What is the one challenge with doing this with substring? How does substring work, and how might it be complicated in this situation? So what would the substring call be that I give to it? So if I say, for instance, substring on my test vector, what would I give it? Yeah, exactly. Some of the codes are 2 letters and some of them are 3. So there is no correct answer to this. If I say substring test vector 1, 2, I get the ID correct, but I cut off the D. If I say 1 to 3, I get CBD just fine, but now I get ID dash. So there are ways you could do this with substring, but it'd be really annoying. You'd have to check how many letters there are and then pick a different substring, which is kind of an awkward way to go about it. But if that was the only thing you had, you could make it work. What might be another approach to doing this? String split fixed might work, and so would string extract. String split fixed will be a little interesting. So if I say string split fixed and then test vector, what should I put after that? Do you remember how this works? What does string split fixed take? So this is string split, but string split fixed. I can look in the help. It says here, it takes a string. I've provided the name of the vector right here. So I said string split fixed, let's string split this, and then it takes a pattern. So if we have this vector that looks like this, what is the pattern we want to split on? What is the thing we'd want to split? Where do we want to tell it to break it up into pieces? Where the dash appears, right? So I could say string split on the dash. The interesting thing about string split fixed, argument n is missing. Oh yeah, first we have to tell it how many things to break up into. How many things would we break it up into? What do all our patterns look like? How many things will this be broken into? It's always going to be 2 things. It's always 3 letters and a dash and something, which we could verify by actually checking the variable. But for now, trust me, they're all like this. If I say string split fixed, we get this. So what is this that's being returned right here? What kind of object is this that it looks like? It's a matrix, exactly. So the way string split works is it takes a single character vector like this, and then it breaks it up so that each one of these things is going to be 1 row in a matrix. And then every time it gets broken up, say by a dash, each piece on each side of the dash is going to get its own column in the matrix. So now we have CBD and 11 and ID and 0, 1. How could I take this exact statement and just add something to it that would give me what I want? So what part of this do we want? We want just the first column. Excellent. How would I take this and modify it to get just the first column? Beautiful. People are machines today. I love it. So, well, slight difference. Other side. Rows are always subset first, columns are always subset second. So you can actually see right here, it would say, give me the bracket and the 1. You could literally copy that there. If I do that, it gives me CBD and ID, because if you subset a matrix to only one row or one column, R automatically turns it into a vector. So here, this ends up with a character vector that we could use string split fixed for, and it'll get it. This is, as you can see, a reasonably complicated way to do it, but it's going to give us the exact same result as any other method we might do. This works perfectly in this particular application. Okay? So this is one way we could do it. Another suggestion someone had in chat was to use string extract. If I say string extract text vector, how might we do it with string extract? Anybody have an idea?
I set up a pattern, and then I assigned the result of string extract to a variable. And then I wound up with a vector that had dashes at the end. So then I did a string replace a dash with nothing.
You could do that. So this is a 2-stage one. So you essentially, did you say, what pattern did you use for the string extract? Oh, your audio's up.
In the first set of parentheses, just dot dot, and then the second one dot or $sign.
So you did like dot 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 $sign?
No, in the second one, yeah. Or the or sign.
Or sign. Can you type it in chat?
Yeah.
My brain probably is not processing what you're saying, and it's much easier for me to just read it. Oh, so you had that. So you had that or $sign.
Mm-hmm.
Okay. So what does this give me? This gives me CBD and ID dash. Ah, so I see what this is doing. This is sort of an interesting thing. So this is any character, any character, any character, or end of string. Is that what you're trying to do?
Yeah, I think so.
Okay, so this ends up actually being exactly equivalent to string sub 1-3. He just gives, this is just going to give you character 1, character 2, and either character 3 or the end of the string if it runs out. So this is that. This could technically work, but it would be the same thing as string sub 1-3. So if rather than give me a pattern in words, how might you or anyone else describe how I might want to get what I want out of CBD11? How would you describe that in English? What part do I want out of this? You could say I want everything left of the dash. You could say I want all the letters, the first letters at the start of it, anything like that. Okay. And so usually when if I'm going to write like a string extract or something like this with a regular expression, I begin first by trying to clearly state what it is that I want. In this case, I might be say, give me everything up to the dash. So one option we might be is to say, well, let's start at the beginning. How do we start at the beginning of a string? Does anybody remember? Caret. How do we say, give me everything? Like anything? So this would be repeated. How do I say any character? That and then repeated would be, we can do that. So this is just going to give me everything right now. But if we say, give me everything up to a dash, this will match everything up to and including the dash. So we could then, for instance, string remove the dash, right? But what is another way we could think about we want this? Instead of saying we want everything up to the dash, what would be a slightly more concise way of doing that? So the example's been provided in chat. I'd say in English, how would you just say, so this says right here, as was provided in chat, start at the beginning and then give me any letter A through Z, and then repeat it as many times as possible. So this way literally could be read in English as start at the beginning of the string and then give me all the letters, but stop when you hit anything that's not a letter. If we do that, we get CBD and ID. So this goes up to the dash, but it doesn't include the dash. So this is one way to kind of take these patterns and play with it. And it just comes down to your way of thinking it out. These will all give you the same basic solution. So for example, what we were getting up to there before was, let me start at the beginning, take everything up to the dash. This gets me up to the dash, and I could then say string remove the dash. Well, that'll give me CBD and ID. String split give me the same thing. These all do the exact same thing, okay? The most concise of them is this one, but because these all do the exact same thing, the correct one is whichever one is intuitive to you and you think of first, okay? So this is one of those ones where maybe in some other class that might be like, there's one correct way to do it. Bullshit. There's never one correct way to do anything in programming. That's not true. There's never like one correct. There might be one way that, due to the architecture of the programming language, is inherently like faster than some other way. But 99% of the time, that just doesn't matter. Okay. The computers are so fast that most of these little differences they don't matter. In this entire thing, technically speaking, I would actually wager this one is probably technically the fastest one, because this one would call out to an external library. So would this, and this one wouldn't. Maybe. But this one is awkward. This one is elegant. This is the one I would normally use. So do whatever you want. Here's a question in chat. Would string detect be another option? String detect is kind of different. So if I say, take this exact statement here, and I say string detect, what is string detect going to produce here? Anybody have an idea? What is it going to find? People have now enough time to run it, so I'll just run it. It's just going to say trues. The reason is because what string detect does is it goes through test vector, and anytime it can match the pattern you give it, it returns a true for that entry. Well, the thing is all of these IDs here begin, they have a beginning to the string, they all have some letters. So they can always match this particular statement. As long as they begin with a letter, it's going to return a true. So string detect isn't super useful in this case, but it would be useful if some of our IDs began with letters and some didn't, and we wanted to figure out which ones began with letters and which ones didn't. String detect is useful for that sort of thing. Okay. In this case, what we want to do is we actually, instead of sort of searching across the whole string and returning a true or false for each entry, we actually want to cut up the interior of the string itself, into pieces, which is typically best done with something like string extract, string split, something like that. There are other ways we could go about this, but these are sort of the three ways that I might normally think about it. Okay. So arbitrarily, and well, not so arbitrarily, because it's the one that I do have in the answer key for this particular homework, we'll go with the string extract here. So if I take string extract, this particular one, and I stick it in my function here, how do I have to modify this string extract call to make it work inside this function instead of just on my test vector? What do I got to do? That's it. Take test vector, but instead of text vector, we replace it with X. The idea is the way this function is going to work is it's going to be a function region extract, which takes one argument X. It's just going to pass that argument over here to string extract, and it's going to run it. Okay. So if I say run this function region extract, and now over here, I can say, I don't even need the X right here, region extract CBD11 and ID. It's going to spit out what I want. Okay. So we've essentially just made a quick shortcut function. This function doesn't do anything different than this. That and that are identical. But this saves us from having this little bit of this in here. It's just what we might call a shortcut function. I usually call this something like a helper function or a shortcut. It's a really basic function that performs some task to save me a little bit of typing. Okay. Any questions about that? Pretty good. Okay. So what we need to do.
Oh, Chuck, can I ask a quick question?
Of course.
Why did you have to do like the C? I understand that you want both of those, but you couldn't just put them in with commas.
No. So if I do them without the C, then region extract thinks this is the first argument and this is the second argument. And so region extract only takes one argument. So it's going to say there's an unused argument. So what it did is it extracted CBD11. It can do that, but over here it doesn't know what to do with that because it thinks it's another argument. But if we do it like this, with that around it, then it's like, oh, well, the first argument is this entire vector. And then it works. Does that make sense?
Yeah, thanks.
Okay. Next question, could the X be a matrix instead of a vector? Well, let's see what happens. Let's just say matrix all equals 2. So we should have a matrix that just sort of repeats that. Let's see what happens if I give region extract test matrix. CBD ID, CBD ID. So it will work on a matrix, but it will coerce that matrix into a vector and then return a vector. So this is sort of an odd thing about throwing a matrix into something like this. This is a function which expects, so string extract expects a vector. A matrix is actually a type of vector. It appears to have multiple dimensions, but it technically has a length. So you stuff it in there, it spits out a vector instead. You probably don't want to do this, but it will work. And it might not be what you're expecting. Okay. Any other questions? Can you explain string extract text vector that again? Yeah, sure. So what I've done here, if I just do string extract on the test vector, and I'm saying, give me all the characters in the string up to a dash, it's going to give me this. It's going to give me every character in it up to and including the dash. Well, I need to get rid of that dash, right? That hyphen, I'd rather. If I add string remove the hyphen, it deletes the hyphen. So it's a two-stage way of getting at the same result. Does that make sense?
Yeah, thank you.
Yeah. Okay. Moving on. So what we need to do is we need to run this region extract on our data to extract regions and make new columns in our data. So what I need to do is on data list station data and data list trip data, I need to make new columns called terminal region and to station region and from station region using this function. So terminal region is going to be in the station data, and then trip data is going to have to station region and from station region. So let's begin with the station data. Okay, I'm just going to display it really quick to show you the structure of these data. Okay, so again, these data are structured such that the actual locations, the terminal regions, are the first characters in the terminal variable here. Okay, so what we want to do is we want to run region extract on this terminal variable and create a new terminal region variable in this data set. Okay. How would I go about doing that? So if I want to add a new variable to the station data, what should I do? What should I start with up here? Okay, we're going to mutate. So we're going to have a mutate call. What should I do before mutate? What are we mutating? What always goes before mutate? Technically, it's the first argument of mutate, but we usually begin with the data set and a pipe. So the data set in this case is station data. Okay. We'll pipe that into mutate. So if I want to create a variable named terminal region, how do I do that? Laboriously make you guys do all the work. Terminal region, exactly. Terminal region is the first name, the new variable. And then what is terminal region the result of? What do I put on the right side of this equals? So we're going to be applying our function to this variable, right? It's set in there. So we would say, how exactly should I write this? I like to look at that a little bit. So is there a reason not to do it this way? No, there is not actually necessarily a reason not to do it that way. It just is a little bit awkward, and it's a little bit of a different setup than we typically do. So I could technically, and it would work just fine, do it this way. But that is a lot of dollar signs, and I tend to prefer to have people get used to using the sort of mutate and tidyverse. You don't have to. This would be a basar way of doing it. Technically speaking, you'd have to. Oh, so this is trip data. Yeah, so that would be from station ID to from station region. So this would work it for trip data. It's a lot of dollar signs. There's a lot of magic going on there. I'll grab this and I'll compare that to the mutate we'll do on the trip data in a minute. So in the mutate, what should I do? I like to look at that from one minor modification. So if I take this straight from chat, terminal, what is the one thing I can cut out of here and actually absolutely should cut out of this statement? Yeah, we really actually don't want to do this right here because this will actually make it fail to work. So if I say run this, it's going to yell at me. It's going to say object station data not found, because station data actually is not a thing in our environment it can find. It's going to be confused about it. We also just don't have to do that at all. You usually basically never want to use a $ operator inside of a mutate or tidyverse pipeline, because what that is going to do is it's going to make it go look for something outside of the pipeline. It's going to go say, so if I do something like data list station data this, it will appear to work perfectly fine. The thing is, though, is it's not, when it says station data list station data $ here, it's not using this station data to do the calculation. It's using this potentially unmodified station data to do it. If we modify station data in any way in this pipeline, like right here, if I did some sort of modification to it, this would not work on this station data. It would instead grab the original data. This sounds weird, and it is. And I will just give you the warning, you do not want to do this unless you really know what you're doing. I'll do an operation like this once in a while, but you'll never see me do it in class because that's a good way to steer people into very dangerous realms. Generally, what you want to do is something like this. If you don't specify the place for terminal to be, it's going to know it's in this data frame you sent to mutate. It's going to look in the right place. So what this says is take my data list, get the station data frame, send it to mutate, then create a new variable called terminal region, which is equal to the result of running region extract on the terminal column. If I do this, It will spit it to console. We'll see the original terminal column like this, 4 BTs, some CBDs. My terminal region is just the BTs, the CBDs, SLU, CBD, right? So this gives me the result that I want. So if this looks good, I'm happy with this result. What one more thing do I need to add to this code here to make my changes permanent to the data frame? I ought to assign it. And in this case, I need to assign it back to itself. In R, you just destroy the thing you want to modify and overwrite it with the new version. So I want to modify my original station data. So I just say my station data, overwrite it with my modified data. Okay. So this will do what I want. Okay. So we've taken care of this. So if I have this code right here, how can I modify this code so that we do the exact same operation to the trip data to generate a to station region and a from station region? So if I just copy and paste this code, what all do I need to change in here? It's a few things we need to change. First thing first, we're not working with the station data anymore. We're working with the trip data. So I'll substitute trip data for station data. Okay, what's the next thing I need to do? You can think about it as one thing or a couple things we need to do. So I'm not making one variable anymore. I've got two different ones. So just as a reminder, if I go and look at my trip data has a from station ID and a to station ID, and we're just going to get a to station region and a from station region. So what am I creating in here? We don't have to be clever here. It's actually kind of awkward to do this with an across function. So I would just say we're going to create two new variables in the mutate. So how might I modify the stuff I have in my mutate now? So two things to do, kind of. We could do it with a cross, but it's a little bit awkward at this thing because we're not modifying the existing variables. We're actually creating two new variables. So I'd have to introduce to you naming rules inside of an across function, and it's a little awkward. With only two variables, I would say probably just do it directly. We could use two mutate functions, but we could also create two variables inside one mutate function. I usually just create them all inside one. What is the contents of this? Okay, yeah, we could add a comma. And then what's it going to look like? Oh yeah, here, I like the look of this. Let me just grab. Yeah, we go. A couple people doing it. So I'm just going to grab, copy, paste that. What's this look like? So this says the from station region is a new variable equal to region extract on from station ID, and to station region is equal to region extract on the to station ID. Okay, I like the look of this. I'm going to first run just this part of it to see what it looks like. I see here, for instance, the from station IDs are like CBDs, PSs. I see my from station region, CBD. My to station IDs are all these PSs. And the to station regions are all PSs. That seems to have done what I want it to do. I'm going to do that and assign it back. Now we can compare the sort of basar way of doing this. So this statement with the mutates, these two statements down here are equivalent. These would both produce the exact same result. So theoretically, you could use either one of them. I kind of like doing everything in this framework. It's what I've grown used to and what I normally teach in the class. But you would also see other people, especially people who are more used to basar, do it this way down here. Technically speaking, it's not that one of them is better in some way. They're equivalent. I just kind of teach this because the mutate sort of has some flexibility in doing some things that can get a little bit awkward using this sort of system, particularly things like doing across functions and grouping on stuff. You can't create like summarizations of variables very easily using this method. You instead have to layer on additional functions, which get a little awkward. Yeah. So here's a question. Can you remind me the preference for trip data in quotes over the $sign? It's more or less arbitrary. So this and this are exactly equivalent, except for when you try to use them in functions. If you wanted to say create a function, I'm just going to call this subset some data, is a function of, let's say, a data frame and a variable. Okay, so I can use this right here and say, I can create a function like this and say, let's subset some data. Let's subset, how about data list trip data, and say, and that will give me the variable that I want. Okay. Watch what happens if all I do is, instead of using the brackets here, I swap this to a $sign. Variable null. What if I do this? Uninitialized column, variable null. You notice how this no longer works with a $sign? The reason for this is you cannot pass a naked variable name like this to a function and have it recognized as a naked variable name over here. It doesn't work. The quotes, however, do. And so the reason I usually provide the quotes like this is because you can use them while writing functions. So this is preferred because you can use this when writing a function. $signs do not play nice inside of functions. So that's kind of the main reason, is I'm using the quotes as the more general way to approach this problem. And people who come from another programming language would see the $sign subsetting as a true abomination. It's the kind of thing that only works in R and not in other languages, whereas this would be the way of subsetting in other languages written by computer programmers. So it's both a pedagogical thing. I think this is sort of a nicer way to teach it. And also, this just doesn't work in some situations, and it's unintuitive why it doesn't work. Yeah. So next one. What's the rhyme and reason as to why some lines of code are shown in an output window when you run them and sometimes not? The rhyme and the reason is they're not shown if they get assigned to something. So this is something about the console in R. The console can be thought of as a dumping ground. If you run a function and it doesn't get captured somewhere, it gets dumped to the console. Think of it as like a valve on something. Some pressure builds up when the computer runs something. If you don't tell it to go somewhere, it has to get jettisoned out into the console. As soon as you assign to something like this, no output is produced. But if I only highlight this and not the assignment, it needs to produce some exhaust and it shoots it out into the console. So when you assign something in R, all you're doing is capturing the output that would go to the console and stuffing it in an object instead of stuffing it in the console. Does that make sense? It's actually the same thing. The console output is literally what gets assigned to the object. But not literally, it's slightly different, but that's basically what's happening. Okay. Okay, yep. And then next. Seems super important. 100% going to forget to spend an hour debugging. Remember this moment with a great big fistful. Yeah, this is one of those things. It looks very elegant to use the $sign, but elegant things often cause problems when you want to use them in complex ways. The ugly way like this is actually the more powerful way. Okay, so I'm going to delete that stuff and we'll stick with this method of doing it because it's lovely and it works everywhere. Yeah, the ugly way does kill the autocomplete. So it goes. Yeah. Okay, so that works. Any more questions about that? These are excellent questions, by the way. These are some of the best questions I've had on this homework in many, many terms of teaching this class. I think this is my 8th term. Spring will be the 9th and last. Okay. Cool. Okay. Let's keep moving. So if we look in data list weather data, there is a column called events. So if I take a quick glimpse of the weather data, we'll see the weather data has a lot of information. It's really rich data on weather. We got all sorts of interesting things. At the moment, we actually really care only about a very simple thing. We care about whether it rained or not. So if we look here and we see events, we see rain, 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 maybe some missing values and stuff. We don't care about all this numeric data up here. So let's zoom in on our rain column, that is our events column, and see what it looks like. So I'm going to say this, and then I'm going to say, let's look at our events column. Actually, let's do a quick count. That way we can see how common these events are. Okay. So this is a sort of also something I would commonly recommend is if you want to know about values of a categorical variable, take it and just send it to count. Count is nice because it produces frequency tables of things. So this is essentially the value and how many rows in the data take this value. Okay? Count is a super handy function. So what we see here is in all of our weather data, there's a pretty large amount of weather data. It's essentially like daily weather data or something. We see that we have 9 fog events, 7 fog and rain, 141 rain, 1 rain and snow, 3 rain and thunderstorm, and 205 NAs. Okay. So if you glanced at this and you didn't know any better, what would you say NA represents as weather? Like what's going on when this is NA? What does it probably look like outside? Sunny. It is Seattle though, so I wouldn't necessarily say sunny or nice weather, but at least it's probably dry. Yeah. Okay. So this events column seems to be capturing any form of sort of water in the air, right? Okay. So if I want to generate a new column in my data that is just whether or not it's raining, what values in here represent rain and which ones represent non-rain? And give me either of them. So non-rain here would be, for instance, fog alone or NAs. Either of these are non-raining conditions. Okay? Similarly, if you wanted to find rain specifically, what do all of the rain ones have in common? They got the word rain in it, right? Okay, so you've got 2 different ways you could approach this problem. You could, for instance, say it's not raining when it's fog or NA, or you could say it is raining whenever I find the word rain, right? Either one of these works. I kind of like the latter one. Kind of makes sense if I want to know when it's raining. Look for rain, right? Okay. So what we want to do is we want to essentially create a new variable in our weather data that is rain or not rain. Okay. So if I'm going to create a new variable in the weather data, what should I do? We're going to mutate. Let's build this out. Keep telling me things to do. So we're going to mutate. Okay, we could use an if else. We could use a string detect. I like the sound of that. Can you show me how that works? So let's say we want to use an if else. Where's the string detect go?
Right after that.
Sounds
Right.
good to me. String detect. What do I put inside my string detect? How does that work?
Events, comma, rain in quotation marks.
How do I, and this is important.
Oop, I'm sorry.
Will this work?
No. Capitalize the R.
Okay. So we've done this. What else do I need to build out in this statement? So I've got my string detect, which provides true and false values.
Before events, do you need to put data list $, weather data?
What would be the best way to do this? If we're going to be using
probably use dplyr.
Yeah. How should I do that?
So that should go before mutate, right?
Yeah, we can do that. Let's pipe it in. Okay. So what else should go inside the mutate first? There's a few more things we got to build out. So
if all that equals true, so like equals true after, yeah.
So what does if else take as a argument? So we normally if else is a logical test, right? So do we have to do equals true? What is this going to take as values?
If rain exists in the vector events, it'll say true.
It'll say true. And so what would this produce? So if the thing on the left is true, what does this statement produce?
A condition.
Okay, well, so if this is true, you're just testing whether it does in fact equal itself. Like it is true. If this is false, then this statement produces a false. This is actually not necessary. This thing here already produces trues and falses. We don't have to test to see if it's true or not. It already is a true or a false. So it will work if you say equals true, but it doesn't actually do anything extra. It's already producing trues and falses. So the intuition is good, but it's just not needed because this string detect is already trues and falses. Okay, so if this thing is a true, how does if else work? What are the next arguments to if else? This can be anyone too. You don't have to. You're not on the spot here.
Give someone else a chance.
So what else do we want in if else? Okay, yeah, I like that. So if string detect in the events finds rain, we want it to be like, yo, there's rain. And if there is no rain, what do we want it to say?
No rain.
Ah, yeah. Yo, there's no rain. Okay, so we want that. So, and here's a question too. Is there a reason to use string detect over string match? In this case, pretty much no. So string match is slightly different. Regular expression. Oh, that's right. String detect. No, wait, what is the difference between string match and negation? Extract matched groups from a string. One column for each capture group. So string match, I think, will extract. Does that extract the subsets? Let's see. String match. So that would return an NA for those, whereas string detect does trues and falses. So theoretically, we could use this we could use string match in a roundabout way to get this, because what we do is do string match on the rain and then replace the NAs with no rain, and that would also work, which in some ways is reminiscent of what we're going to have to do here in a second. So if I run this here, what's one other thing we need in the mutate? We just have this if else sitting here. What do we want to do with the result of this if else? Yeah, somebody actually did it up there. We want to assign it. I see now. We want to say rain equals the result of that. If I run this, okay, no errors, that's always good. If I scroll to the end, look at what our problem is with this. We get rain correctly. When there's rain, we get rain. But notice that when we get an NA, we still get an NA over here. Okay? So this is problematic. And the reason for this is if you string detect in a variable and there's nothing to search in, there is an NA, a missing value, string detect returns an NA. So this is slightly annoying. There's a couple different things we can do here. One of the most straightforward things, well, actually here, let me suggestion is what to do. I'll answer that question there in chat after somebody gives me an idea of what we might do to solve this. How might we solve this? Let's see what that does. So let's say string detect events and rain, and then slightly, well, so this is saying or is not NA. So might not be exactly here. Let's see if I can get a one line here. There we go. Okay, so what is this statement here actually saying? This says string detect, look in events and see if you find rain. If so, return a true. Or if events is not missing, return a rain. So the issue with here is that there are in fact non-missing values which are not rain. It won't work for fog. Okay. So what might be another way we could do this? I'll give you one example that theoretically based on the logic would work, which is to reverse this and say, if it is not rain or it is an NA, then it is in fact no rain and otherwise rain. This is a case where it's easy to think of a negative situation, but not the positive is harder to get. But this still may in fact not work. Oh, actually it does here. That's kind of nice. So this is kind of funny that this works. So this right here returns an NA sometimes. This over here, though, never returns an NA. And in the behavior inside this if-else statement, whenever this one is NA over here, this one ends up being true. And it's happy enough that this is a true and it's okay with it being an NA over here. So this sort of solves our problem in a roundabout way. Another thing that we could do, for instance, is do what Samuel's recommending here in the chat, where we could have a multi-part case when statement. So let's do that as an example. I'm going to leave this one here because it works. Let's start with this. So let's delete this over here. Do a case when. So if we wanted to do this with a case when, what would I normally do first? So we've only used case when a couple times in this class. So how might we go about doing this? We essentially have 3 different conditions. How might we test them? Anybody have an idea? There's the same conditions we see up here. We might modify them a little bit. What might I want to do? You can say these verbally. You don't have to provide me the exact code. So what do we want to do? Keep in mind case when is essentially the same as if else, but we can give it more than one logical argument. So what would be the first thing we'd want to test? Let's say we're running through this events column. What would we want to test? Detect string for rain. We could do that. So let's look for rain. And what do we want to do whenever we find rain? Yeah, we want it to be rain. It's okay not to remember the syntax for case when, but you just say, if this thing is true, then we'll do this. This is essentially, this is a test over here. It produces this thing if the test is true. Otherwise, it keeps moving. What would be another thing we want to test? So when does this test not work for us? When there's NAs. So we might then say, well, if events is NA, we want to be no rain, right? Okay. We could do that. What would be left? It would be the fog one, right? I think it would be a little bit awkward to do the fog, so we might instead rearrange this slightly, and I'll show you why. So let's say, I'm just going to, as an example, say, if you find fog, no rain. Now, what is this thing going to do? Okay, well, actually, they fixed case 1 a little bit, so this actually works. In my opinion, this actually probably shouldn't work, but it does. If you write a statement like this, I would very strongly recommend that you begin with the NA testing first. I would say, first thing, deal with your missing values. If something is missing, just assign no rain. If it is not missing, then it's going to come down and test the next statement. Go search for rain. If it doesn't find rain, I would say default to there being no rain. You'll get the correct answer like that, but the staging is a little bit different. So here's a question. String detect events, exclamation point, beginning rain. You probably don't want to do that. Well, one, actually, the exclamation point doesn't work that way inside string detect. You could put the exclamation point on the outside. The real problem is that there are certain cases with rain where rain is not at the start of the text. So we can't just look at the beginning. So you just want rain anywhere. Yeah, this is sort of the finickiness, right? There's so many little dumb things about this sort of thing where you're just like, well, this doesn't work and this doesn't work, right? So here's a great question. Why do we want the missing values to be no rain? This is sort of an intuition from the data. So here, there's fog, fog and rain, rain, rain and snow, rain and thunderstorm, and there's no value for no precipitation. So we're essentially inferring from sort of knowledge from outside the data that an NA means no precipitation. So we're kind of guessing based on the presence of the data. This is the kind of thing you do with a real data set you got with no documentation. You're like, NA here probably means there's no rain. Okay. So here's a question too. What's the true doing? Or say, I know it's a correct thing to put there. I know what it's doing functionally. So why is this the way to do it, are you asking? So the general philosophy of this is the way case when works is case when tests this. Anytime it returns a true, it returns the thing on the right. If this returns a false, it goes to the next line. The problem is that you don't want it to get to the end of it and have a statement that returns a false and have it go looking for another thing. Because then it's going to run out of stuff to search and it's going to return a missing value. This just basically makes sure it's impossible for it to return a missing value because it's going to run down the list and no matter what, there's going to be a statement returning a true. Yeah, it's basically 1 = 1. It's just a true. So it's always going to be true. This is a good sort of philosophy for doing these case wins. Yeah, anything left over will come up as true. So in fact, often in my projects, what you'll actually have is if I believe every statement up here is fully exhaustive, so every statement together should cover every possibility, I will put down here something like that, because there shouldn't be a value that makes it all the way to the end. This is how I build error checking into my variables. Nothing should make it past all my prior statements. So if it does, something broke and I need to go and diagnose it. So this is a good thing about case when. You can write if-else statements with it that build in a check for when things break. So I use it this way all the time. In fact, I often use case when even generating binaries because it allows me to put in missing data checking and stuff like that. It's just sort of a general way to go about it. No, it actually won't crash. It will instead, if I scroll through, it will, in fact, just produce NAs where it fails. So it ends up with missing data for the cases not covered by these statements. Because something that has, for instance, fog as its event does not have a missing NA. It also doesn't contain rain. The test fails, it gets an NA. Yeah. Is there any way to halt if it reaches the oh crap scenario? Kind of. I think it's going to get upset with me if I do this. Yeah, it doesn't like that. How about, in fact, it shouldn't work. This shouldn't work. Yep, that's going to break. Okay. Yeah, there's basically no way to introduce an actual stop in case when. Because the way case when actually works is even if that line has no cases associated with it, it's still evaluating the code. Because what it's actually doing is creating a lookup table and then matching to it. And so it won't work. So you can't actually make it stop that way. What I would do instead is I would build unit tests like an adult programmer, which would be I would sort of go true, error, and then when later on I would eventually have a unit test that basically looks in this column for error values, but you'd have that outside of it. Unit tests should be kept separate from the rest of the code. I don't teach unit tests in this class because there's enough time to do it, but if you take like software development courses, unit testing is really important, and you'd normally do that separately rather than inline. Not always though. Yeah, I would prefer to do it this way and then just look for them using like count and then address them. Okay. Any other questions on that I missed? I got just about everything. So that basically worked. This works perfectly fine though, and I'm just going to use this. Verify that. Looks good to me. It's either no rain or rain. It's exhaustive. I like it. Okay. So next thing. Hopping along, we're getting there. Probably speed up slightly, but okay. So now what we have is we have bike station information and rainy weather information. What I want to do is I want to merge these data together to join the trip data and the weather data by trip start date, just to add the rain column to the trip level data. All we care about is the rain column and not the rest of that crap. Okay. So if I want to do that, we're going to create something called trips weather, and we're going to assign some data to it. How should I go about doing this? You can give me a conceptual idea or walk me through the code, provide me anything, and we'll get moving. So what do I do? Oh yeah, the perfect start. Well, we're going to create something called trips weather. So we begin with that. So trips weather is a combination of everything from the trip data and one column from the weather data. So normally I would say here, it makes sense to probably begin with the trip data because we're going to keep everything in it. So I'm just going to say, let's start with the trip data. Okay. So before we go into that, what are we joining on here that it says? It says we need to join the bike info and the rainy weather info at the trip level but we're going to be joining it by the dates. Okay, so if I glimpse at the trip data, where are the dates in my trip data? Is there a date column? There's a start and a stop time. So there's no date dedicated column, but there is a date inside the start time and the stop time. So what we want to do is we want to get a date column out of this. I say specifically here that what we should do is some kind of date manipulation or extraction from the start time column. So what we're going to do is we're going to match the weather data to whenever the bike ride began. Okay, so if we want to do that, we're going to essentially create a new variable. So what do I do to create a new variable in my trip data? Yes, we're going to mutate. So for simplicity, I might name this the same thing that's in the weather data. So I'm going to really quickly glimpse and check over. The date in the weather data is called date. So let's create a column called date. Okay. So again, if I go back to my trip data, I want to extract the date from this date time object. Does anybody have an idea how we might do this? And I'll say now, you might be thinking of something complicated in some way, and it is not complicated. How might we convert a date time object to just a date? It's not even as complicated as MDY. So remember, MDY and HM and all those are for converting strings of data to a date time object. This is already a nice date time object. So if you imagine that you have something that is date time, which is a type of data, and you want it to be treated as if it was a date, how might you do that? Let's say that you have a numeric variable, and you want to be treated like a character data. How would you do that? As.date. So this is the great thing, right? As.character would be convert numeric to character. Well, here, this is a date time. To make it a date, you just say as dot, and I can scroll down and find it. A lot of these as dots, there's an as dot date. As dot date, start time. So what this says is take this start time object, make it a date. To do that, all it's going to do is strip off the hours, the minutes, and the seconds and make it a day. Okay? So you don't have to use any of that lubridate shit. You just can go, boom. If I go over here, all the way at the end is a new date object, which is a date column type. Okay? As.date. That's all we got to do. Okay, we now have a date. Okay? So if we now have a date, how can we go about taking our weather data and sticking it on to our trip data? How do we go about doing something like that? Want to take data frame 1 and data frame 2 and make them happy friends. So I like something like that. I like doing it with like a left join. You could do it with a left join, a full join, inner join, kind of depends what you feel like. Full joins tend to give you missing data. But when in doubt, left join is a good place to start. And to answer the question there, is as.date, it's actually as.date, is an automatic function like as.character? Yeah, if you mean automatic function as in it's built into basar, yes. Or if you mean automatic as in we don't have to tell it how to work, yes, that too.
Thank you.
So if we want to left join our trip date onto our weather data, what do I put inside my left join? We will put the date in there. What do we normally put first in the left join? We'll get to the date and we'll talk about how to do it. So what are we left joining to? Yeah, the names of the two data sets we're joining. So the thing is because we're piping these data into the left join, the name of the first data set is already in there, kind of, because we've piped the first trip data in. So what is the only thing we need to add? We need to get rain, but it's in that. There we go. It's the weather data. So this is saying we need to take the trip data here and then mutate and create a new date column, which we need to do the join. And then we're going to left join that to the weather data. If I do this, it's going to automatically say we're joining by the date variable because that's the only common variable between them. And it's going to join them. So we're going to get a whole bunch of temperature and shit. We're going to get all this stuff over here. Okay. The thing is I actually really only care about the rain variable inside of this. So what might I add? We're going to add a couple things. What might I add to this to make it so it only gives me the rain variable? So yeah, I like that. I'm going to say, let's select. And what do I put in the select? This is a mild trick question. So what do we actually need to do this operation?
Rain.
We need the rain, but what else do we need?
And date.
Exactly. We still need the variable we're going to join on. So what we're doing here, if I run this code, is we've just cut the weather data down to the rain column and the date column, the date being necessary to perform the join. If I do all this, we're going to get as output all of our trip data, and then we're going to get just added onto it the rain column from the weather data. Okay? That seems to have done pretty much what we want. Does that make sense? You notice here I didn't actually have to specify the column we're joining on. This is because the only common columns between the two data sets are the date column. We could make this explicit and say by equals date, and that will do it. But we actually, in this case, we don't have to. It's one nice thing about not having common names. Okay. So this will get us what we want. This will get us a big trips weather data frame like that. And now we finally get to go back to, instead of having lots of dumb brackets and text, we've got everything we want in a single trips weather data frame. We can finally stop double bracketing everything. Okay. Questions about that? Problem, mutate input, character string, not a standard unambiguous format. I input data as date start time. So what that probably is if you go up, well, actually, first, what I would do is I'd look at your, so most likely it's this causing the error here. I would look at a glimpse of your trip data and make sure that your start time is a date.time object. If it's not a date time object, then you need to make sure the code in the last section of part 1 converts it to a date time. In which case, if you scroll all the way up, you'll see it's probably this code right here missing. Yep. I do not envy my replacement in teaching this class in the future because they will not have an encyclopedic knowledge of everything that can go wrong in the homework assignments to know where to troubleshoot things. It's going to be a traumatic term for them. Okay.
I have a question.
Yeah.
Can you go back up? So why is there that pipe in the middle of the left join? Since that statement wasn't done, do you need a pipe there?
Which statement wasn't done?
So the left join. I'm used to thinking of pipes as coming between manipulations.
Yep.
But the left join hadn't been closed yet. So why is there a pipe in the middle of it? What is that doing?
So what this is actually doing, this is kind of order of operations stuff. What it's actually doing, so the whole pipe together is going to run data list weather data, select down to rain and date. It's going to create that object and then place it as the second argument to left join here. and still pipe the result of all this stuff into there and then perform the join. So order of operations is kind of fun. You could put an arbitrarily long pipe inside of the function, and before it runs the exterior function, it will run everything inside of it.
Could you have done that without the pipe, just by doing another extraction?
Yeah. I mean, you'd have to do something funny like this.
Okay.
Equivalent statement. So the thing about pipes is pipes actually don't do anything except allow you to write your functions left to right instead of inside out. There's no magic going on. It just executes this the same way as it would any other kind of subsetting. You could also do it with brackets if you wanted.
Do we need to put by equal date in after the weather date part?
Yes, actually. So left join is expecting its first argument to be a data set. If I put by equals date here and then do this, I would think it's going to get confused. Actually, it still works. You got to love these dplyr functions that can do things they really shouldn't be able to do. Yeah, so it doesn't care what order the arguments are in. It's smart enough to figure it out.
Thank you.
It shouldn't do that, but it does. They're very smart. Everything else in the R world requires your arguments to be in order if you don't name them, but a lot of these dplyr ones figure it out. And the programming required to make that work is mind-bending sometimes. So I try and put them in the nice order.
Thank you.
Okay, so the grand finale. What we're going to do, the whole culmination of this assignment here, is we need to write a function, which I'm going to call daily rain rides, that is going to take two inputs, two arguments. It's going to take a region code and a direction for the rides. That is, we'll do something like, say, I want to look at all the rides involving the central business district, specifically coming from the central business district or going to the central business district. That's all we're going to give it. And what it's going to do is it's going to subset the data and then draw a ggplot of the sort of entire year's worth of rides going to or from that particular region. Okay, this is essentially a template building function for generating plots. Okay, so what is this function going to do? It's going to do a lot of stuff, and it's going to do them in order. What it's going to do is it's going to filter the data for the trips that come either from the stations with the given region code or to those stations. Okay, so it's going to do some code like this, filter down to these things. We're going to get there. It then will make a data frame, a temporary data frame with one row per day, counting how many trips were in that region code going that direction. Okay. And then it's going to use that temporary data frame to make a scatter plot with those things and then draw some lines through it. I've created a little skeleton for it, and we're going to walk through how to do this piece by piece. Okay. There's a lot going on here. This is the kind of thing you wouldn't write the entire function beginning to end in one go. We're going to write it in little pieces until it does mostly what we want to do and then kind of adapt it. Okay. So the first thing that I want, right? So how about, let's get an example. Actually, I don't need an example. So what we're going to do is we're going to make this function. It's called daily rain rides. It takes a region code and it takes a direction. Okay. So let's say that what I want to do, I'm going to put it here in the body of here. We're going to create a data frame, like a temporary data frame. I'm just going to call it here a temporary data frame. If I want to create a temporary data frame when this function runs, that first just contains, so let's say I want to make this work so that if I say CBD, so region code CBD and direction to, it gives me only the rides going to the CBD. How are we going to go about that? Let's look at our data. I look at my trips weather. So what column here would indicate that we are going to the central business district on a particular ride? How would we find that? To station region, which we created from to station name. So that's correct too. So if we wanted to get then, let's say I have my trips weather. How could I get only the rows for the rides going to the central business district? What do I need to do here to this data frame? We're picking rows, so we're going to filter. What would I put inside filter to find things going to the CBD? How's filter work? I like that. Getting slightly ahead of where I'm going, but that'll definitely work. We'll say to station region. If we just wanted to go to CBD, we could say this will filter down to all the rides that are going to the central business district. So if I scroll over here, you'll see the two station IDs are all CBD ones, right? So we are going to use the region code for this. So I'm going to grab this right here as an example. I put it here. Okay. Well, this will get, if we want to go to the CBD, this will work. But what happens if we want to use this direction to control what happens? How do I make it so that this is, when the direction is to, this is to station region, but when the direction is from, it's from station region? How might we do some kind of changing like that? This requires thinking slightly outside of the box. It's not something we can even do directly in the filter statement. How might we make it so this variable changes depending on the direction? Anybody have a broad idea? You just spoken, you don't have to tell me the code. Just generally, what would we want this to do? Can you use an OR statement? This is exactly kind of what we want to do, right? We want this to run code that looks like this. When do we want it to run this code? Like this exact code like here, so as was provided earlier. When do we want it to run this code? This is valid when? We're checking the to station. So this would work perfectly when under what condition? Or conversely, when does this not give us what we want? For rows where the to station region are equal to what we input for region code, this does what that. But the thing is for these two arguments, region code and direction, this code works for whatever region code we give it, but it only works for one direction, right? Which direction does this work for? It works for two. So what would be the equivalent statement that works for the from direction? What is the only thing we'd have to change here to make it work for the from direction? Change the to station region to the from station region. Okay. So imagine we have these two pieces of code. So how would we make it so whenever the direction is to, it runs this, but when the direction is from, it runs this instead? People remember how we might do this? How do we make it execute this code? So
Well,
it's kind of if and else, which oddly enough in R is a different thing from if else. We actually don't want to do with case when, because we straight up don't even want to run the other code. So we're going to run an if and an else. So if you remember at all the syntax, we have an if, we have a logical statement, and then we have some squiggly brackets that say do some stuff inside of here. So when do we want it to run this first code? What is the logical statement that gets tested? If the direction equals 2. Okay, so this is going to tell our function, when the direction is 2, I want you to take the trip's weather data and filter it down to the rows where the 2-station region is equal to the region code we pick. That gets what we want. What do we want to do if this isn't true? How do we make it do something else?
Just go on to the next.
What goes here? Yeah, that was, I accidentally said it. I'm so used to saying it. It is in fact else. Else we want to do this. But we specifically want it to only take 2 arguments here. So what might we put right after the else? We might say, if this, otherwise else. We could just do squigglies. But normally what I would say is put another if to test again. What is the next logical statement we want to do? Well, if it's not 2, what is it instead? Yeah, it's direction equals from. And you might be asking me, well, if it's not 2, what else could it be? The reason to make it so it only takes direction equals 2 or direction equals from is you probably want it to kick an error when people make a typo. You don't want to just assume it's always from if they misspelled 2. You'd hope people don't misspell 2 too often, but you never know. And so it's better to make it explicitly only take these values. Okay? So now what this does, and I can just show you, this should theoretically work. If I say daily rain rides going to the CBD, oh, I need to make it. In this case, I need to tell it to return that DF just to display it. You'll see it has returned to me only places that have a 2-station region, 2 of CBD. Well, we've just successfully created a really simple function that subsets our data based on a couple rules. Okay, so we're 1/3 of the way to having our function do the thing we want it to do. Okay.
Why do you need that else for the if? Can't you just have 2 independent if statements?
You can do that. In this case, it will be the same. This is what's considered slightly better syntax in that it runs this thing right here and only does the second statement if the first one fails. Otherwise, it would attempt to evaluate both of them. In this case, there should be no way both of them could run, but you could think of other cases where both could run, and you want to avoid that if they are mutually exclusive. Oh yeah, and this should definitely be from station region. Good catch. This is why copy and pasting is bad. Do as I say, not as I do. Okay. Now it works. And we can be sure, because if I swap this to from, I should get ones whose from station ID are all CBD. I could swap this to like Belltown. Their from station IDs are Belltown. Their 2-station IDs are not. So this appears to work. Questions about that? This is taking advantage of flow control, fundamental programming stuff, but it will enable you to make really flexible functions. Because this thing actually just straight up operates completely different code depending on the arguments to the function. which, as a matter of fact, is actually how most R functions work. They have all sorts of code that doesn't run when you run the function. They only run little bits of it when they're needed. Okay, so the next step of this, right? We've essentially finished this. Check, we're done with that. The next thing, though, is that we want to create a data frame called tempdf, but what it should contain is 1 row per day, counting how many trips were in that region code going that direction. Okay? This should have columns for the trip starting date, how many trips there were that day, and whether there was rain or not that day. I say you'll need to use group by and summarize, but technically we can use a shortcut function. So we basically have a function here. So far, it creates the tempdf. So if I want to modify this tempdf to aggregate that data that way, how might I do that? So what do I want to get, right? I have 1 ride per row, but what I want is 1 row per day. How can I aggregate my data to get 1 row per day? And remember, our data look like this inside the function. Or as a more abstract question that might get directly at it, if you have a bunch of data and what you want to do is count how many of a particular type of observation there are, how might you go about doing that? In this case, how many trips are there per day? How might you do that? Yes, you can use count, right? Count is an aggregator. So if you wanted to count how many rides there were per date, what do? What are you counting? What are you counting the values of? What's the variable? What here captures the day? And to respond to that, grouping by day and doing a sum of n is exactly what the count function does. So if we say count on the date, okay, what that's going to do, and I'll just show you real quickly. If I say daily rain rides that, let's say return what we actually want to do is return our tempdf here. We're going to modify it. If I run this function, what we're going to get is this is each date in the data, and this is the number of rides there were on that particular date. We now have an aggregation function, but we need one other thing. We want to also know how many rides there were by whether it was raining or not. How do you think we might modify this to also get whether it's raining or not? Or might I have to change? I'll tell you, it is incredibly simple. We're aggregating over the date, and we're aggregating over whether it's raining or not. So what do I need to add? Yeah, comma rain, right? I'll show you. Now it spits out the date, whether it was raining or not, and the count of rides. If you remember, whether it's raining or not is a day level variable. A day cannot be both raining and not raining. So essentially all this did is capture whether or not it was raining on that day and gave us the exact same counts we had before. This is just one of those ways you can use count to just tack on another variable if you need it. It doesn't actually change anything except give us a rain column. Okay. So what we got now is we have a beautiful function that counts how many rides there are on a given date and then whether or not it rained. So you're getting an error here, temp df not found. So what you'll want to do is you want to make sure that your syntax looks like this, that you have daily rain rides as a function that takes a region code and a direction. It checks if direction is equal, so double equals to 2, and direction equals to from. Because that error is indicating it can't find temp df, which means it didn't run this code or this code. If you can't figure that out on first glance, copy and paste it into the chat. I'll probably be able to find the error real quick. Yeah, Courtney, exactly. If it was possible to have rain and no rain on a date, count would end up with, if there were both of them in a date, you'd end up with 2 rows. The number of rides when it was rain and the number of rides when it was not. Okay. Let me copy what you got right here. Okay. So I see exactly what's going on. So this right here, you have outside of your function. You're missing a closing bracket. That should be good. Then if I copy this, paste this here, let's run your function and see what it does. It runs perfectly for me. Okay, there is a closing bracket. So make sure your trips weather data, or is your trips weather data up in your global environment in the top right? Because it requires the trips weather data. Okay, and you're still getting, when you run this function down here, you get an error, can't find temp df. And you have trips weather. What would cause that? So you run daily rain rides, and you're running, run that, and you get that. That is a good question. So you glimpse trips weather. It looks exactly like mine. 142,000 rows, roughly. Looks like that. Has a date column, has a rain column. Okay. But this fails to run. Specifically with temp df not found. So that indicates, would normally indicate it's not running this or this because it's not creating the temporary temp df. But I have your exact code here. It's working for me. So the syntax, yeah, let's figure it out. I may have to have anyone currently having that issue. If it's not something they can find, send it to me and I'll check it out. It'll probably be something simple, but that I'm not capturing from this because it's clearly not in the function itself. So I would suspect it's somewhere else. Curious. Okay. So I'll keep going here and then hopefully we'll figure it out. Yeah, because this looks exactly the same as mine. Okay. So if what we want to do is use this temp df to draw a plot, right? So what we want to do is we want to create a scatter plot of date on the x-axis. So it says date on the x-axis, the number of trips on the y-axis, and I want points colored one way for days with no rain and another way for days with rain. Okay, so how would I create a plot in here? And we can just plot like we normally would. That would plot temp df with date on the x-axis and the number of rides on the y-axis. What does that code look like? How do I normally plot just about anything? Like the look of that. It's a nice starting point. So we got a ggplot. We're going to say we're going to plot using the temp df. What's on the x-axis and what's on the y-axis. And there's one other argument we're going to give it. What's x? What's y? Also a parenthesis missing. X is date. Y is n. I'm going to tack on one extra thing. We want them colored by whether it's raining or not. If we want to draw a scatter plot, what do I add onto this for a scatter plot? I like it. On point. Okay. I'm going to just do that. Now, our daily rain rides draws a scatter plot of, by the day of the year, a scatter plot dot for whether or not it rained, the number of rides on that day, and you can see, as you might expect, bike share rides are more common as you get into the warmer, drier summer months, and they're pretty low over here in the winter, and they follow pretty closely the pattern of whether there's rain or not. On average, the blue dots tend to be over here where it's overall depressed. Okay? So our function is now a really kind of neat scatter plotting type function. So we've managed to do a lot here. There's a couple of other things you'll want to do. I say here, for instance, you'll want to control the dots to be black and deep sky blue. I'm going to leave that up to you to figure out how to do. It's pretty easy. I will just add on this. If we do scale x date, actually, it looks like it's automatically applied it. Modern ggplot is great. It shows a date. We could clean up in here and change the labels and stuff. For instance, I'm going to leave it alone. I think that's pretty good. That's pretty good. You could use scale x date if you want. And then you're going to clean up the titles, the axes on here. You'll fix that color thing, which is just going to be a scale color manual type thing. You'll just set the values manually, like values equals a named vector of the appropriate colors. And then you might do something like throw on a geom smooth, which might draw nice smooth lines showing you the trends in ridership across the year. You can do anything you want like that. But the neat thing about this is we can now do stuff like, let's look at going to the CBD, daily rain rides. Let's look at UW station, coming from UW station. This is what the power of functions is now you essentially have an analytical tool that can quickly display graphs for all of these different places. And you can see the patterns are similar, but the overall counts and stuff are different. This is what it's useful for. You'll probably find practical uses for this as you get deeper into your sort of R career. The homework, you just need to display about 3 different ones of these and make sure to clean up the axes and stuff. And that's about it. Okay. Anybody have any other questions other than the 2 folks who I'm going to troubleshoot here?
I would also like troubleshooting help after you've dealt with.
Great. Here's a great question. When would you want to use something like this as opposed to facet wrapping from a process point of view? It could be that what you actually care about is searching for particular things. Perhaps there are too many things to facet over. It might be the case, for instance, that the combination of the stations and the to and the from results in a very large number of options. Or perhaps you're doing something like writing an interactive application and you want people to be able to browse through them. Common things like that. I write a lot of functions for these for a variety of different reasons. Sometimes I want to be able to quickly call different types of models. For instance, in my dissertation stuff, I have to like queue up large series of models, and I prefer to have a single function that takes a couple different arguments that I can like apply over and generate a series of them rather than manually doing each model. You come up with a million reasons to do stuff this way, but it's regard with facet wrapping, you just don't want to display them all at the same time. It's the main thing. Okay, anything else quick ones? I mostly just, before I start troubleshooting, I need to quickly run to the restroom because I've been guzzling an entire bottle of water the entire time we've been doing this. Okay, I'll be right back. And for those not needing troubleshooting, I'll see you on Wednesday. Okay, I return. Okay. So everyone currently is having the same issue. Is that my understanding? It's kind of given an error about can't find temp df.
So it actually just worked for me. I have this question, like, how come if I just type temp.df or temp_df, it says it's not there, but like the plots and everything works if I do daily_rain_rides.
Oh, that's an excellent
confused.
question. And so the idea for that is, and this is sort of an interesting thing, everything created inside of a function like tempdf only exists inside of the function. So basically when, for instance, like daily rain rides runs right here, it creates tempdf, but it creates it only inside of this function and not in your global environment. So you can't access tempdf, but the internal part of the function can. What it's essentially doing is sequentially running all the code inside the function. Once it finishes running, it deletes all those temporary objects it created. So you can't access them outside of the function, but everything works inside of it. This is actually a thing called scoping, and it is beyond normally what I would explain in the class, but the gist of it is that the global environment contains stuff you always have access to anywhere in your script. There's actually many different environments that exist at the same time. And you normally only have access to the stuff in your global environment. Your function has its own environment where everything else happens. Hopefully that helps explain in some way, or do you have more questions on that?
Yeah, that explained it. I was just being terrified I'm not having the temp_df, and then I just tried it on the other stuff.
Nope.
Thank you. Thanks.
Yeah. Did that, so is anyone else still having that same error or something similar, or any other error?
Yeah, I'm still having the tempdf error.
Okay. So the tempdf error. So you can run like this whole thing and daily rain rides appears perfectly fine up here. And then if you then type daily rain rides, no parentheses, and run it, you should get code that looks something like this or whatever you have. Can you copy the thing that gets printed to your console right here and put it in chat? And while you're doing that, does group by date rain and summarize equals count date rain? You can't do summarize equals count. Count only works on data frames itself. You could instead do group by date rain, summarize, and then just say like n equals n parentheses. Count only works on a whole data frame, so you'd use it like this. The equivalent using summarize would be that would be the equivalent with summarize.
Thank you.
Next one, Tristram says, aesthetics must be valid data columns, y equals n. Mistype the name of a data column, forget to add after stat. That's probably indicating you have used tempdf and count here like this and assigned it to tempdf. May have to have you paste that code to check. So here, let me grab this code really quick. Okay. Okay. Direction equals 2. Yeah, looks pretty good to me. Let me just double check that. Daily rain rides, that worked. I'll have to add a return temp df. That is working perfectly fine for me. So it has to be something higher up. Can you do glimpse trips weather and what would be a good way to check? You have from station region to station region properly spelled?
Yep.
Okay.
I have the same number of rows and columns and everything.
Okay. Anna, there, the reason you're getting that is you'll notice that your true statement has a uppercase rain. Oh yeah, and then a lowercase rain in the first one. So you actually have, because it's case sensitive, you've created 2.
I see, thanks. I took it out and I thought maybe that was the issue, but then the NAs were replaced, so yeah.
Yeah, okay. So let's see, to fix this, I'm trying to think of a concise way to have you show me what's in your trips weather, because it's got to be. Can you show me what's in this chunk up here? For me, it's 205, but where you create trips weather.
Oh.
Yeah, let me just find it, sorry.
Yeah, you're good. Okay, copy that and see. It's identical to mine. Huh, yeah, and if you've got 2 station region from station region, they look like that. You should have everything you need, so long as this date column also looks good and there's a date object type. So then the question is, what is going on down here? How are you running your code? Are you just doing Control Enter inside the chunk?
No, I select what I want and then I run it.
Hit Control Enter. Okay. Or run. How do you do?
Like that, yeah.
Okay. That should be fine. You may have to email me the RMD to take a quick peek.
Okay, no problem. Like right now or?
Yeah, shoot
later?
it to me right now and I'll just check it out. Here's a question.
Okay.
Why do we want to convert rain variable to factor and step there, identify rain days? Oh yeah, I have that in there. I recommend you convert to a factor because we're going to use it later as a essentially as a factor in ggplot, but it actually isn't going to specifically matter. ggplot will automatically convert character data to a factor when you run it. It'll be perfectly fine either way. I tend to, when I wrote this one, I tended to like more often to explicitly do it, but factor handling got so much better from when I first put this thing together that it honestly doesn't matter as much anymore. Yeah. Okay, let me see if I've got. See if I've received it. Okay. Did you email it to me, or did you have, maybe I should have just Slack it to me.
Yeah, I'm going to my email now. Sorry.
Okay. Let me know once
I sent it to your email. Yeah, it should be coming soon.
Okay. If it doesn't show up pretty quickly, I might have you Slack it to me. Every once in a while, there's sort of a curious delay on UW emails, especially with attachments. Might be grumpily. Doing something wrong here. Let me see that. Oh, it just popped up. So let me grab it. Okay. Data list, trip data, mutate, left join, weather data, select terrain date by date. That actually looks pretty good to me. Yeah, that looks perfect to me. That should be equivalent. If there's a problem that's not there, but it might be somewhere else. Okay, let me grab this one, pop it open and see. Okay, show this in a folder. I'm going to put this in the correct folder. Oh, come on, where are you at? Okay. Triple S foot right, ignore. Put it here. Okay, let's pop open yours and then quickly. Wipe everything. Okay, that looks fine, that looks fine, that looks fine. Let's run it all the way down to there. Okay, that looks pretty good. CBD, that looks good. Daily rain rides. Okay. And then daily rain rides, CBD. That works perfectly for me. So what I would recommend doing is clearing your global environment or closing your RStudio and opening it back up again, and then going down, opening this up, going to this chunk and pressing the run everything prior button and making sure it gets up to here, because it works perfectly for me from your RMD. Okay,
can you try looking at just tempdf alone? Because when I do that, because when I try to run it, it runs without problem. But when I look at tempdf alone, it tells me exactly that.
Yeah, it won't exist.
Okay.
So tempdf will not exist because it's only created inside of the function. So what's happening is when a function runs, any objects created inside of it forever exist only inside the function. Once the function is finished running, they get deleted. And so you won't be able to access them. So it won't be able to find that, but this will work.
Okay. All right. I'll try closing stuff and reopening. That might be the problem.
What is the SLU in your instruction for the plot title? So that's, for instance, if you had like daily rain rides SLU, you would just say that you're going to or from the SLU station. So I'm just saying you make it so the title updates to say it's the specific station. So make the title so it dynamically updates to be rides from SLU, rides to SLU. I probably should have covered that one during the full lab, but people can figure it out. Exactly. Okay, so let me see.
All right, try to use summarize, group by and summarize.
Yeah.
And then there is an arrow.
Let me check it really quick. Okay, daily rain rise equals.
Thank you.
Okay, so right now there's a. So this is n equals this. You want n equals n. So you're missing an n right there.
Oh, can you explain a little bit about why we use n equals n here?
Yeah, this is actually a function. It's the n function. The n function is a count type function that can be used inside summarize. N gives you the number of rows in the current groups. Yeah, so it's a very specific function you only use inside a summarize. Yeah, it's confusing here because you're creating a variable named after this function, but they're actually this n and this n are totally unrelated. This thing over here is a function n, and if you do like question mark n, you'll actually see it gives the current group size. It's just a function.
Thank you. But when we use count, we don't need to assign n.
Nope. You just say like this: count, delete that, and it does exactly the same thing. Those are actually equivalent statements.
Thank you.
Yep.
Okay, so I've run everything up to this point. Should I try now running this box as well?
Yeah, so what do here is go up here to the top where it probably says eval equals false. Turn it over here to eval equals true really quick because you want to make sure it runs the chunk, and then just press the green button and see what it does.
Okay. It seems happy with me.
Good, and then make sure you've
all
got
ran
it.
perfectly.
Do you have a daily rain rides like SLU2 and run that and make sure it works?
Yeah, it worked.
You're good. So it was probably
Excellent.
something up above that got modified or changed in some way that was messing it up, and when in doubt, kill it and restart it and
Perfect.
fix it. Okay.
All right. Thank you so much. Really appreciate it.
Yeah, no problem. Okay, anybody else got anything?
I had to duck out for another professor's meeting for about 10 minutes when you were discussing the join function, and I got it to run, but I was just curious to see how you did.
So I did it, this is exactly the same code, but I did it basically this first one up here. Just said, take the trip data and then create a new date column and then left join it to the weather data, keeping only the rain and date columns, join everything by date.
Okay. And so if you pipe left join to a select, it's selecting things from your weather data?
No, I haven't actually piped the left join into anything. I've piped the data into it.
Okay. So at the end, after the entire join, you're just selecting those two columns.
No, it's actually inside of the join. So this is actually, it runs this first, gets only these columns from the weather data, and then, yeah.
Oh, okay. I thought, okay. I did something like this, and I'd just be curious to know if there's any unforeseen dangers in this one, or if it's...
That's literally equivalent.
Okay.
Yeah, by using the right join, it's equivalent to the left join over here. So no, it's totally equivalent.
Thank you very much.
Anything else? That's it. Okay. Stop.